In this video, we are going to talk about 10 steps that we can take to speed up our renders and to have better renders, better quality renders with more details and less noise using Blender's Cycles render engine. So remember, we're going to talk about cycles, not EV. Before we can start, I'm going to show you something that you already know. Looking at this image, you probably guess what I'm going to say. If you want to render faster, you will definitely lose some quality. If you want higher quality, you will have to spend some more time. So you always have a trade-off. So you don't have a magic button that you can press and get faster renders and higher quality images. So this is why I'm going to divide the steps into two groups. So 5 steps to speed up your renders while keeping the quality, while trying to save the quality, and also 5 steps to increase the quality without spending too much time or reducing render time at the same time. So we're basically trying to find that magic button, I think, or magic trick. First, let's look at faster renders. What kind of steps, what kind of things that we need to know to render faster. So the first step is very obvious. It's about hardware. No matter what hardware you're using, you need to keep some things in mind. For example, if you have GPU in your computer, please use that. Make sure that you're using GPU. And if you're using a laptop, please make sure that you plug in your laptop and use electric power, right? Do not rely on battery. So this is one image rendered using my laptop. As you can see here on battery, it took 16 seconds. While plugged in, it took 10 seconds. Also, I know there are some settings on my laptop which I can kind of change, tweak. But anyways, whatever I do, I get better, faster renders when my laptop is plugged in. So I tested in 3 laptops and all of them showed faster renders when they're plugged in. So this is that scene, and please make sure that you're using GPU here. Please change from render settings to GPU, and if you don't see it here, you can come here to render preferences or just preferences and come here to system and change to one of these GPU settings. CUDA is for older NVIDIA graphics cards, OptiX is for newer ones, HIP or HIP, I don't know, AMD, and this one is for Intel. So I have RTX cards, so I can use OptiX, or you can change to whatever you have. So the next thing that we need to know is keeping samples as low as possible. It's not something that you can do immediately, but it's something that you shouldn't do right away. For example, when especially beginners, when they try to render, when they try to get higher quality, they go higher in sample count. For example, I don't know, 512 or 1000 samples, but it greatly increased the amount of time that you spend to render. So we're talking about faster renders now. So please look for other solutions to get better quality. Do not increase the sample count, because it's not the best thing to do, and it really works against the time. So we will see how to keep samples low and get great qualities in the coming tips. So let's go. The next tip is to increase noise threshold. If you're using adaptive sampling in Blender, please try to increase noise threshold. Do not use default number. I will show this now. So this is where you find noise threshold. By default, it's turned on and the number is 0.01. Just change this to something like 0.1. Do not go very high, just use 0.1. It's a really good number. Actually 0.01 from 0.01 to 0.1 is a good number, 0.1. Actually 0.1 gives a good result. It kind of decreases the quality, but it speeds up render time greatly, especially when you're using higher amount of samples. For example, 256 or 512, just use 0.1 or something close. So here I rendered the image with 0.1 in 10 seconds, as you can see here, in 10 seconds. And the same settings, just noise threshold is default number 0.01, and it rendered in 14 seconds. This one is in 10 seconds, and you can see the quality. It is from overall look, there is no big difference here, but when you look into details, there are some differences. This one looks better. For example, look at this sofa. Here, for example, you have unnecessary details, but overall it's not too bad. It's okay. And for this reduced time, it's worth actually changing. Definitely play around with this noise threshold number. So the next tip to speed up your renders is to use OptiX denoising. Actually, OptiX denoising works only on RTX cards. It denoises very fast, faster than Open Image Denoise, but at the same time OptiX kind of loses some quality when you use OptiX with the same amount of samples. We will see that. So the next tip is change tile size accordingly. There is something called tile size. I'll show you this now. So you will find tile size here in performance settings in your render settings. So use tiling, and here I have 2048 for GPU, and when you change this to CPU, you should decrease this number, maybe, I don't know, 128 or something, because when you're using, it's a general rule, when you're using CPU, just keep this number low. When you're using GPU, make it, I don't know, maybe 1024 or even 248 or something. If you have a lot of video memory, you can increase this tile size. So here you can see two examples. In this case, I rendered with my CPU, and the tile size was 128 pixels or something, and it rendered in 2 minutes and 9 seconds. And with 2048, which is default tile size, it rendered in 2 minutes and 24 seconds. So if you're using CPU to render your image, change this to lower number. Like you should see, I think 64 is okay. For if you have a powerful CPU, you can increase this 128 or 256, but I think generally 128 is a good number for good CPUs. And you can see you can save a good amount of time by only changing the tile size. And tile size also plays a role when you're rendering with GPU. And here is another example. When you are using GPU, you need to increase this tile size. By default, it is 2048, and my GPU rendered this image in 13 to 14 seconds. But when I decreased this to 128 tile size, 128, the time increased to 18 seconds. So tile size must be bigger, must be larger for GPU renders, and it must be smaller for CPU renders. Now these are 5 steps to render faster. Of course, there are other ways to speed up your renders, but we will talk about this later too. So now let's see how we can get cleaner renders with more detail. So here the first step is to increase the resolution of your image. That might sound crazy, but it's actually a good solution. I will show you why right now. So first of all, how do we increase the resolution? What I mean by increasing resolution. The resolution of this image here, as you can see in output properties, we have full HD now, but we can increase this up to 4K if we really need detail, if we really need to have clear renders. So do not hurry and go to increase the sample count. Don't do that. Just come here and increase the resolution if you really need details and less noise. I will show you different examples now. So here is an example of resolution versus sample count. Here I went crazy high with the sample count, and I changed the samples to 4000 here, but here it's 128. I just forgot to save this file, so I re-rendered it in 4K. You can just see it from here. For example, this is full HD, and this has 4,000 samples. This one, and it's using Open Image Denoising. This one is 4K. You can check it from here. This one is also using Open Image Denoising, and both look fine. But if you need smaller details to be visible, just increase the resolution, because let's go closer and look at the details here and here. There is so much detail here, as you can see, and anywhere you look, this image looks cleaner and higher quality. Look at the flower, for example, and from here. Simply, there is not enough pixel here. Not enough pixels to for the denoiser to pick up and calculate a really good image. There is not enough pixels to show you the information, the texture detail and things. Look at this pillow. Look how much more detailed this is. And the time is, the difference in between time is amazing. This one rendered in 5 minutes. This one is just 50 seconds. The same settings, I just changed the resolution to 4K, but kept 128 samples. Here I went up to 4,000 samples, but it was just full HD. So if you need higher detail, just increase the resolution. Of course, it increased the time, but it's much better than increasing the sample count. So the next step is to use path guiding or light tree. I will show you some examples now. So here there is an image. It's not very high quality because it's just full HD and 128 samples. But here I turned off path guiding, but here path guiding is on. So if you need brighter images, you will need to turn on path guiding. Really important thing is path guiding only works with your CPU, not GPU. When you're using GPU, you can just forget about it. So as you can see, I'm using my CPU here, and here path guiding is on, here it is off. You can see it just gives more light and sometimes more details and more better colors. For example, here better details. Look at this pillow. Path guiding off, path guiding on. So it really makes a difference. It is brighter and much better. Light bounces are better here. So in order to turn on path guiding, you should be using CPU, and if you come here, I've enabled path guiding, you can just disable or enable it. Now let's look at light tree. You can use light tree both with your CPU and GPU. You can just come here and turn on light tree. In GPU it is also available. So what light tree does is to try to minimize the noise in your render. So this is why I rendered this nighttime image with denoising off. As you can see, there is no denoising, and LT, which is light tree, is off here. And let's look at this image. Here light tree is on, and you can see the time also increased a bit, 15 seconds and 13 to 14 seconds. Light tree on, off, on, off, on, off. So light tree gives a bit more brightness and less noise, but it doesn't work always, especially when you have bright scene, daylight scenes, or if your object is very well lit. You don't need light tree turned on. I just checked it in, I don't know, maybe 4 or 5 scenes, different scenes. It usually works better when you need more light. And also, if you turn on denoising, if you see here, I turned off denoising. Oh, sorry. In both cases, denoising is off. This is why you see a lot of noise here. If you turn on denoising, you don't usually see a really big difference if you turn on light tree or off. So, but with higher sample count, if you are not planning to use denoise, or if you're using some third-party denoising programs, you definitely need to turn on light tree, especially if you want to have less noise and brighter images. Here it is making a big difference. It is giving a bit brightness and much less noise, if you can see that. So the next step is Open Image Denoising over OptiX denoising. Just use Open Image over OptiX because OptiX kind of washes away a lot of details, kind of smoothens or over denoises, I don't know. But Open Image Denoising generally preserves detail much better. Not really much better, but a lot better than OptiX. But OptiX is faster. So if you need cleaner renders with a bit more time, also Open Image Denoising uses your CPU, not GPU. So if you don't have GPU, you will only use Open Image, so you will not have OptiX. So you can skip this step if you are using only CPU. So the next step is more samples for animations. When you are rendering animations, you will definitely need more samples, because to get cleaner renders, to get smoother animations, you need more samples for animations. Rendering animations is really different from rendering still images. For still images, most of these solutions will work, but for rendering animations, you will definitely need more samples. Do not try to use these these tips, and try to get a really good animation render, and you will not get. To get better animations, you will have to increase the sample count, and do not use denoising, or use denoising in a more clever way. Usually, to get a really good animation, better animations, we usually increase the sample count to, I don't know, maybe 1,000 samples at least, or 2,000 samples, and use third-party denoising programs, because in order to denoise animations, you need to look at a few frames at the same time, and a few frames at the same time, and kind of calculate the noise patterns looking at a few images and try to kind of fit them to each other. But when you're using denoising in Blender doesn't care about different frames. It tries to kind of denoise each frame in a unique way, and when you put them side by side, or when you watch them in an animation, which is essentially an image sequence, you will definitely notice really big differences between each frames in terms of denoising. So your animation will just kind of break. So in order to avoid this, you will need to have really high numbers of samples, and if possible, try to use third-party video denoising programs. There is something called temporal denoising or spatial temporal denoising. Just look at the internet and try to get some information about that. So denoising animations, rendering animations is more difficult and really different from rendering still images. So the next thing we need to know is some other things. We will talk about some other things now to get cleaner renders or faster renders. We have a few options here, and many people say that you need to play around with these with the light path settings. Yeah, of course you can change a few stuff here. For example, in light path there are some presets here. For example, you can change to full global illumination, and your scene will get brighter, but it will be a bit slower. Actually, you can just use default. Default is a great number. Don't go very high. And also you can change a few things. It's a bit more advanced, but for example, for diffuse light bounces, you can go lower, like 1 or something, or even I don't know, 2 or 1. But if you decrease this, your overall scene will get darker. And also you don't need to increase this volume, because if you use these presets, this will create volume. If you don't have volumetric shading in your scene, don't need this. If you don't have transmission, if you don't have lights coming from windows, you can just decrease this transmission number. If you are not using glass materials, if you're using glass, just increase. If you are using transparent shader in your materials, you definitely need higher number for this. But if you are not using transparent shader, just bring this to 0. Let's see what happens if we bring this to 0. As you can see, our scene gets really dark because we do not let rays from the windows, because my glass material here is using transparent shader. So I need to have transparent numbers. And also transmission. Look at this glass table. If I decrease this transmission number, if I give it 0, look at the glass materials. You can see the light, depending on how you set up your materials. You can see the light is coming through the windows, the glass material, but the glass, you cannot see through the glass, as you can see here and here. So if you have glass objects, but you don't see them in your render, you can just turn this off, because it's very costly. It really increases render time if you have a lot of light bounce for transmission. You can change this too. And volumetric bounces are also really expensive. It takes a lot of time. If you have any volumetrics, try not to use volumetrics a lot. So, and glossy shaders also, it will change a lot of things. Let me turn this to 20. Actually not 20, because final is total is 12. No matter how high I go here, the final will be 12. So I can come here to make 12. And you can see this glass here, glass at top of this table. Look what happens if I go to 0. You can see how dark it is now, but if I increase this like 4 or even 12, you can see if you have glass objects, you need to change transmission, glossy, and also transparent. So glass objects are really expensive, glass materials. So if glass objects are not very visible or not very important, you can just decrease them. And also caustics, these, if you disable them, your scene will get darker. And also some caustics will not work properly. So these are some of the options in light bounces. And also you have here fast GI approximation, especially when you're rendering interior scenes. You can turn this on, and by default it made it darker because we need to decrease this distance, ambient occlusion distance. Let's give 4, and you can see it's fast, it's noiseless, but it is not very realistic. It's ambient occlusion lighting actually. You can use add method, not replace, add method to really make your scene very bright, and you can change this factor to 0.2 or something just to get more light to places where you have dark shadows. You can increase the brightness with using fast GI approximation, but it actually takes away from reality. So please keep this in mind if you're using fast GI approximation. But for outdoor scenes, it's not very useful, or there is no sense, there is no meaning in using it. But in indoors, you can use fast GI approximation if you don't need very realistic renders. This is everything that I wanted to show in this video. Of course, there are other stuff which you need to be careful, but they're kind of more advanced. For example, render time also depends on the complexity of your shaders in your materials, and sometimes the HDRI that you use in your world. If you have very high definition HDRI, sometimes it can also have some sort of effect. And yeah, so materials will also, and the lights that you use in your scene will also affect render times and the quality. So a good news is by default a lot of things are fine in Blender. You don't need to touch many things, you don't need to change a lot of things to get high quality renders. Generally the things that I showed in this video are usually enough for most of the projects.